Hello guys, welcome once more to another video on our YouTube channel. So in today's video we are going to be proving one of the logarithmic laws which is written clearly to you. We are going to prove that ln A plus ln B is equal to the ln of AB. So stay tuned as you watch. Don't forget to like, share and subscribe to the channel. Also comment on the video so that we can produce more interesting videos for you to come and watch. So let's get started. Alright, so to prove this, I'm going to recall some basic concepts of calculus to you guys so we can better understand what we are going to be doing in the proof. Alright, so if I consider a graph, for example, on the xy plane, that's a curve of f, and then I consider the lines x equal to a and the x equal to b. Now you realize that the area bounded by the graph of f and these lines can be defined as a definite integral. So that area bounded, the area under the curve of f bounded by the lines x equal to a and x equal to b is simply defined by the area a equal to the integral from a to b of f of x dx. For example, if I ask you to find the area bounded by the lines x equal to 0 and x equal to 4 and the curve y equal to x, first of all you're going to display the curve to me. Okay, that is, you draw the line y equal to x. Then now x equal to 0 is simply the origin, and x equal to 4, that is the line x equal to 4. So we need to find the area of the portion of this portion. So using the definition of that area, we are going to say the area is equal to the integral from 0 to 4 of the function, that is x. When we integrate x, we have x squared on 2. We fit our boundaries 0 to 4. We just need to fit the upper bound, because when we fit 0, the lower bound, when we fit the lower bound, the resulting integral, the resulting function is going to give you 0. So just have 4 squared over 2, which is 16 over 2, which is 8 square units. You could also interpret this area as the area of this right angle triangle half base, whose area is half base times height, because you can see a right angle triangle here, right? The base is 4 units and the height is simply the y coordinate of the y coordinate when x is equal to 4. When x is 4, y is equal to 4, because we have the line y equal to x. X and y have the same coordinates, have the same values at every point. So that is 4. So the area is going to give you half base. The base is 4 and the height is also 4. So you're going to have half of 4 times 4, which is still 4 times 4 is 16 divided by 2 is 8 square units. So this is the basic concept we are going to be using to prove that the ln of a plus the ln of b is equal to the ln of ab. So let's get straight to proving that. Alright, so to prove that the ln of a plus the ln of b is equal to the ln of ab, we are going to use integration, and we are going to consider a function that when we integrate that function, we have the ln of x. We know that function is 1 over x by definition. When we integrate 1 over x, we get the ln of the absolute value of x. But definitely we are going to be working in a positive interval, since for the ln of a and the ln of b to be defined, a and b are all supposed to be positive. Even if anyways, so we have to draw the graph of 1 over x in the positive interval. It is simply the graph like this. Okay, the horizontal axis is a horizontal asymptote and the vertical axis is a vertical asymptote. So here is a graph of 1 over x, that is f, in the positive values, in the positive interval. Now after doing this, we now consider, maybe I just consider 3 values of x. We have 1, we have a, and then we have ab. It's clear that since a and b, bon, in this case, for me to make it convenient to work with, I'm going to consider a to be greater than 1. Okay, I'm going to consider a to be greater than 1 and b to also be greater than 1. So if a is greater than 1 and b is greater than 1, it means ab is definitely greater than a. All right, so we clearly see that this portion here, the area of this portion, that is the area bounded by the curve of f, the lines x equal to 1 and x equal to ab, is simply the area of this portion. Okay, Also, you realize that for the area of this portion is simply the area of the of this curve bounded, the area under this curve bounded by the lines x equal to 1, x equal to a, and the x-axis specifically. So we are going to define those areas as integrals, and from here you can also see that the area of this big portion, okay, the area of this big portion here is equal to the area of this portion plus the area of this portion. So that's what we are going to use. So the area of this big portion, like we said, is the integral from 1 to ab of 1 over x dx, which is equal to the area of this first portion here, which is the integral from 1 to a of 1 over x, plus the integral plus the area of this other portion, which is the integral from a to ab of 1 over x. Now when I integrate 1 over x, I get ln x. Since x is already in a positive interval, I need now to fit the limits from 1 to ab. When I integrate 1 over x, I still have ln x from 1 to a, and here ln x from a to ab. If we fit the upper limit, we have the ln of ab. When we fit the lower limit, the ln of 1 is 0. So this just gives us the ln of ab. Now this is going to give you the ln of a minus the ln of 1, but the ln of a is ln of a and the ln of 1 is 0, plus now the plus, in fact I just rewrote back this integral, that is the integral from a to ab of 1 over x dx. Now we are going to see how to actually integrate this. Okay, now how do we integrate this? We are going to do a substitution. We are going to let x to be equal to a times u. U is a variable. We differentiate both sides. We have the x equal to a du, since a is a constant and u is a variable. Now we need to change the limit when x begins from a to ab. So when x is a, our u is equal to 1, because our u is simply x over a. So if x is a, our u is going to be a over a, which is 1. And when x is ab, our u will be ab over a, which is b. So our u will begin from 1 to b. It therefore means that this integral here, which we need to find, is equal to the integral when x is a, our u is 1, and when x is ab, our u is b. Now our 1 over x, since our x is au, we are going to have 1 over au, then our dx is equal to a du. The a's are going to cancel, and we are going to have that integral to be the integral from 1 to b of 1 over u du. If I integrate 1 over u du, I get ln u, but we are supposing that b is positive, so the interval 1 to b is a positive interval. Therefore we just write ln u without putting the absolute value. When we fit the limits from 1 to b, we are going to get ln b, okay, ln b minus ln 1, but ln 1 is 0, so it just gives us ln b. It therefore means that our ln of ab is equal to ln a plus ln b. So that is a proof. In the next video, we are going to be proving the ln of a to the n is equal to n times the ln of a. That is in the second video. Alright, so thank you guys for watching. Make sure you like, you share, you subscribe to the channel, and you comment on the video if you learned something new. See you guys in the next video, and stay blessed.